Okay, so this question talks about fractions, and it's talking about Simon's thirds. Spent a quarter. What fraction of Spock only had left? So basically, we're talking about the whole is equal to 1 as a fraction, so 1 over 1. And we've got a third and a quarter spent, so we've got to add those two together to be able to work out what's left. And what we need to remember when we're adding fractions is we need a common denominator. So here we'll talk about twelfths. That's the lowest common multiple of 3 and 4. And to turn thirds into twelfths, we've multiplied by 4. So that's going to be 4 twelfths. And to turn quarters into twelfths, we've multiplied by 3. So that's going to be 3 twelfths. We're adding, so we're talking about adding twelfths. So our answer will be twelfths, and 4 plus 3 is 7. So that's how much was spent. So 7 twelfths spent. So what's left is 1 take away 7 twelfths. Well, we need to remember that whole 1 is the same as 12 twelfths. So we're taking away 7 twelfths. That'll leave us with 5 twelfths. Because the question said, work out the fraction of his pocket money that he had left. So the answer is 5 twelfths. So again, fractions when you're adding, common denominator, and then work it through. So here we've got a question that says add a third and a twelfth. Well, we'll look for the lowest common multiple of these. Well, we can see that 12 is 3 times 4, and that's already twelfths. So we'll times this one by 4, and then that'll give us 4 twelfths. We're adding 1 twelfth, so the final answer there is 5 twelfths. Didn't need to change the second one because that turning into twelfths, you can add the twelfths straight away. When you're timesing fractions, simplest practice of all, this one, for fractions, we times the numerators, times the denominators, and we end up with 3 twentieths. And what we need to remember is that when we're timesing, we do not need a common denominator. So we just simply times across 3 times 1, times the bottoms, 4 times 5, numerators together, denominators together. So that's that one. So we've got a question here where we've got a fifth of them do that, 3/8 do that, all the rest do what fraction? So again, we're talking about a whole situation here. So we need to add the fifth and the 3/8 to work out what we've used so far, whole. And the lowest common multiple of 5 and 8 is 40. So we're going to turn these into 40ths. And just remember the way this works, guys. If we want 40ths, then we've got to ask ourselves, how did the denominator change? Well, they multiplied by 8. How did the numerator change? We've got to change in the same way to make them equivalent fractions. So 1/5 is the same as 8 40ths. And then to do 8ths into 40ths, well, 8 into 40 is 5, so it's 8 times 5, so we do 3 times 5, so 15. You must times the numerator and the denominator by the same factor to give you an equivalent fraction. We're adding, so we've got 40ths, so 8 plus 15 is 23. So we've got 23 40ths in total for the swimming and everything. So we've got to do 1, the whole, take away the 23 40ths to see what's left. Well, the whole 1 is the same as 40 40ths, so we take away the 23 40ths. I'll give you an answer in 40ths. So 40 take away 23 is 17. So the answer here will be 17 40ths. So for this question, we're adding 2/5 and 3/8. Well, again, it's about common denominators. So we need 40ths. 5 times 8 is 40. And then we've times the 5 by 8, so we times the 2 by 8. We've times the 8 by 5, so we times the 3 by 5. So we're making out a common denominator. So this is going to be 40ths. 16 plus 15 is 31. So the answer here will be 31 40ths. This question is asking us to do some work with mixed numbers. So when we're doing a takeaway sum, the easiest thing to do is to do the whole number parts first. So 5 take away 2 is 3. And then we've got 2/3 take away 3/4. But again, common denominator needed when we're subtracting fractions, just like when we're adding. 3 and 4, common denominator will be twelfths. 3 goes into 12 and 4 goes into 12. To times by 4 to make the thirds twelfths, so 2 times 4 is 8. and I had to times by 3, so 3 times 3 is 9, and we're doing a takeaway, so 8 take away 9 is -1, and we're talking about 12s. So our final answer comes from combining these to give us our final mixed number answer. So we've got to do 3 take away a 12th, because the negative is telling us to do a takeaway. 3 take away a 12th, well, the 3 is made up of 2 whole ones plus another whole one, and that other whole one is 12 twelfths, and then we're taking away a 12th, and 12 twelfths take away a whole 12th leaves us with 11 twelfths, so the answer will be 2 and 11 twelfths. Taking away a 12th from 3, we know the answer is going to have 2 and something left, so turn that whole bit into 12 twelfths, makes it a bit easier to see what you're doing. 2 and 11 twelfths, the final answer. This question is asking us to do a sum where we've got to do the bracket first, and then we take it away from 1. So the bracket is going to be talking about common multiple is 6, lowest common multiple is 6, 2 goes to 6 and 6 goes to 6. So a half is 3/6 and 1/6. So I'm doing 1 take away all of that, so it's 1 take away 4/6. Because we're taking away 6, turn the whole one into 6/6. Take away 4/6 is 2/6, but we must remember with fractions we want the lowest possible terms, so lowest terms, so in other words we simplify, and 2/6 will both divide by 2, so 1/3. So the final answer there is 1/3. This question is asking us to work with division, and when you're multiplying and dividing, it's really important that you make your life easy. And the way we do it when multiplying or dividing, we turn everything into fractions. This is the way that will always work. And what we mean by that is if we've got something like 4 divided by 2/3, then we need to rewrite this as 4/1 divided by 2/3. So that we've got both parts as fractions. And we're going to do the same here. We're going to turn this mixed number into a fraction, be an improper fraction, but it's still a fraction, one number on top of another, one whole number on top of another whole number, of course, for a fraction. And we've got to say to ourselves then, how many halves are there in 12.5? Well, in 12 whole ones, there'll be 24 halves, plus the extra 1. So there's 25 halves in 12.5. And we're dividing by 5/8. And what we do with division is we take the reciprocal of the second fraction and then turn this into a multiplication sum. It's much easier to do that. So 25 over 2 stays the same, but we take the reciprocal of this, which means we flip the fraction over to become 8 over 5. Remember, the idea of a reciprocal is that 5 over 8 times 8 over 5, that becomes 40 over 40, which is 1. So when you take the reciprocal, you're really saying what do you multiply the original fraction by to give you an answer of 1. A quick way of thinking about it is if you've got a fraction, the reciprocal will be the flip of it. So in other words, you've reversed the order. Now we've got a multiplication sum. Well, again, that's fairly straightforward now. So multiply the numerators, multiply the denominators. So 25 times 8, 200, 2 times 5, 10. So the final answer here, 200 divided by 10. Both of these divide by 10 itself, so 20 divided by 1 is 20. So the answer here will be 20. Another example of a subtraction sum. When you're subtracting with mixed numbers, as I say, easier just to do the whole number parts first, so 3 take away 1, and then deal with the fraction parts. So 2/5 take away 3/4. We need a common multiple, a common denominator, so the lowest common multiple will be 20. So we're going to turn these into 20ths. 4 times 5, so 4 times 2. 5 times 4. Yeah, so 5 times 4 gives me 20, so 2 times 4 gives me 8. 4 times 5 gives me 20, so I do 3 times 5, which is 15. And this gives me 8 take away 15 is -7. So we're talking about taking 7/20ths away from the whole number part we had here. So we combine these for the final answer. So we're going to end up doing 2, take away 7/20. Well, that's equivalent to saying we've got 2 whole ones can be split into 1 whole one plus 20/20. So basically I've changed one of the whole ones out of this into 20/20. We're taking away 7/20. So that leaves us with 1 and 20/20. Take away 7/20 is 13/20. So when we're doing, say, takeaways, then easiest way, take away the whole number parts, take away the fraction parts. Don't worry that you get a negative, because all it means is you're going to do a takeaway from what whole number parts you had left there. So take one of the ones out of the whole parts, turn it into 20ths in this case to do the takeaway, and then you got left the answer. So this question talks about a full glass of water holding 1/6 of a bottle, so that's important. And it says how many glasses of water can be filled from 2.5 bottles of water. Okay, so they're really saying 2.5 divided by 1/6. They want to see how many 6 go into there to work out the number of glasses that can be filled. Again, when we're dividing fractions, the way to do this is we need 2 fractions. Now this one's already a fraction, so that's no problem. But this one we turn into an improper fraction. So how many halves are there in 2.5? Well, one of the ways you can think of this is you do 2 times 2 is 4 plus the 1. And that gives me 5 halves. That works all the time. So if I've got something like 3 and 3/5 and I want to know how many fifths there are, then you could just do 5 times 3 plus that 3. So 5 times 3 is 15, plus that 3 is 18. So 18/5 is the same as 3 and 3/5. Literally because in each of those whole ones is 5/5 plus 5/5 plus 5/5. Each of those is a whole one, so 1, 2, 3, plus the extra 3/5. Then you're going to get 18/5 for that one. In this case we're turning halves, so we end up with 5 halves. Then the division sum becomes a multiplication to make it easy to do. And in doing that we take the reciprocal of the second fraction, so that flips over to become 6/1. And 5 6s are 30, 2 1s are 2, 30 divided by 2 is 15. So we can fill 15 glasses from 2.5 bottles. This question's given us 2 fractions to think about, and it's saying which is the larger fraction. You've got to show you're working, so it's important you do that. And we could use the grids, or we could use any other method, of course. It says you may use the grids. So I'm going to make equivalent fractions because I think it's probably a quicker way of doing it. And I'm going to look for a lowest common multiple between these two. So I'm going to make 20ths and turn that into there. We multiply by 5. So we do the same to the numerator. So 15/20. And 4/5, I can turn that into 20ths as well, so we can compare like we'd like. And we have to multiply by 4, and we have to multiply by 4, so 16/20. So we can see that this one is bigger than this one. 16/20 is bigger than 15/20. So 4/5 is the larger fraction. Now if you were to use the grids, then you're literally thinking about what does 3/4 look like. Well, we can see going across here that we have quarters. So 3/4 would be all of those. So that's a quarter, that's a quarter, and that's a quarter. On this one, if we come across this way, we can see that that will be 1/5. That'll be another 5th, another 5th, and another 5th. So on this one, we shaded 15, and on this one, we shaded 16. So again, you could use the grids if you wanted to make the comparison. Either way, you'll end up making 4/5 the larger fraction. Now this one says change 5/8 to a decimal. Now we've got lots of ways of doing this. We either recognise the standards. A half is 0.5 as a decimal, a quarter is 0.25 as a decimal, and an eighth is 0.125 as a decimal. These are ones that you really ought to know, guys. So we recognise that 1/8 is that, so 5/8 is going to equal 5 times 0.125. Well, we know 5 12s are 60, 5 5s are 25, so when we combine those we get 625, so the answer here will be 0.625. If you don't remember those, then you've got to remember the standard technique. This means 5 divided by 8. So we set up a division box, and we're going to say how many 8s are in 5, but because we're going into decimals, then we add on a few zeros to help us do this. Still going to be worth 5, just the zeros will help us do any carryovers and things. So we say how many 8s into 5? Well, it doesn't work, so the 5 is the remainder, so that moves over to the next place. We've got a point, so put a point there. Now we're saying how many 5s, how many 8s are in 50, so 6 8s are 48, so it's going to be 6. 48 from 50 is 2, so the remainder of 2 goes over to the next 0. How many 8s in 20? 2 8s are 16, so that's going to be a 2, and 16 from 20 remains as 4. How many 8s in 40? 5 exactly, no remainders, so we end up with a terminating decimal of 0.625. No carryovers to go any further, so no recurring decimal or no repeating pattern that goes on forever. So the answer is 0.625. This question is asking us to add fractions, so we've got to remember when we're adding and subtracting fractions we need a common denominator. The lowest common multiple of 5 and 7 is 35, so I've had to times that one by 7 and I've had to times that one by 5. So that gets times by 5, that gets times by 7, so we're adding. So 14 plus 5 is 19, 19 35ths. So the answer here, 19 35ths. This question asks us to multiply. Well, like I was saying earlier in the video, when you're multiplying fractions, you're best to write them as 2 fractions. So we've got mixed numbers here, so we'll turn these mixed numbers into fractions to make the multiplication easy. In 2 1/2 there is 5 halves, and in 1 3/5 there are 8 fifths. Remember, we just do 5 times 1 is 5, plus the 3 is 8. Each of those whole ones has 5 fifths, that's why we're doing the 5 times that. And each of these whole ones has 2 halves, so 2 times 2 is 4, plus the 1. When you're multiplying fractions, very straightforward now, times the numerators, times the denominators. So we've got 40 over 10, which is 4. Again, just recognise that when you're multiplying the fractions, we do not need common denominators or anything. You're literally multiplying the numerators and multiplying the denominators. So no changes on the bottom here. Just simply multiply them across when you multiply. So when you're adding and subtracting, do change things. Okay, so here we've got this word reciprocal. Well, what we need to remember is that when you're timesing two things, they must give you 1 if one of them is going to be the reciprocal of the other. So here we're saying to ourselves 0.8 times something must give us an answer of 1. So it's a simple rearrangement. I want to know what that something is, so it's going to be 1 divided by 0.8. Now you either know what the answer is to that straight away, or you go through the process of doing your 0.8s into 1 and so forth, or you recognise that 0.8 is the same as 4 fifths, so this is doing 1 divided by 4 fifths, and when we turn this into a multiplication sum, it becomes 1 times 5 over 4, so the answer here will be 5 quarters, or it'll be 1.25. 5 divided by 4, 1.25. We could check this out, of course, because if it works, then 0.8 is 4 fifths. If we multiply by the reciprocal of it, then it must give us an answer of 1. So we think the reciprocal is 5 over 4. So 4 times 5 is 20. 5 times 4 is 20. 20 divided by 20 is 1. So our reciprocal works. If you didn't know that 0.8 was 4 fifths and you weren't sure what to do here, then remember you could have done the division box. So you could have done 0.8 into 1. But you wouldn't have done that. You'd have said how many 8s go into 10 to make it an easier sum. We'd have multiplied this by 10 and multiplied this by 10. And then we'd have said 8s into 1 doesn't work, so we push the 1 over the remainder. 8s into 10 goes 1. Got some remainders to carry over. 2. 8s into 20 is 2, remainder 4. So then we've got how many 8s go into 40? 5. So the answer would have been 1.25. So whichever way, you end up with 5 1/4. Or 5 quarters, sorry, which is the same as 1.25. Write down the reciprocal of 4. So we're saying 4 times something must give us an answer of 1. The reciprocal of a number always multiplies by it to give it a final answer of 1. So our question mark divide by 4, so it's going to be 1/4. So the answer here, 1/4. And we can check it out. 4 times 1/4. Remember, when you multiply, you need 2 fractions, and 4 whole ones is 4 over 1. and 4 times 1 is 4, 1 times 4 is 4, and 4 divided by that is 1. So again, our check works. The next question says, Maria correctly converted each of these fractions to decimals, put a ring around the fractions to give recurring decimals. Well, recurring decimals just mean they repeat. So the standard recurring decimals are things like a third, which is 0.333 going on forever, so we've got a dot there. And any multiples of that will then be recurring, so 2/3 would be recurring, 4/3 would be recurring, and so forth. And we have other fractions that recur, things like seventh, which is 0.1428571, and so forth. So there are lots of decimals that fractions that recur when you turn them into decimals, and the repeating patterns. So let's have a look through this list. Well, 2/5 is 0.4, so that's no good. 5/8 is 0.625, so that's no good. 6/10 is 0.6, so it's terminating, so that's no good. 7/12, interesting, what will 7/12 be? Could do it by hand, but we'll just quickly do this, makes it easier. Yep, that's recurrent. So 7/12 is going to be recurrent because that's 0.583 and the 3 went on forever. 9/15, well, let's have a look. This cancels down, so let's make it a bit simpler to deal with. So divide that by 3, divide that by 3, 3/5, and that's 0.6, so that doesn't recur. So there are 2 fractions in here that recur. The third, 0.333, and the 7/12, 0.58, and then the 3 goes on forever. So those are the 2 that you circle. Worth 2 marks, so they were kind of giving you a clue that you were looking for 2 of them. Write down the reciprocal of 4. Well, we did it a moment ago. 4 times something gives me 1, so this is the reciprocal. And question mark then, divide by 4 will give us the question mark on its own, so a quarter. Work out the value of this, give your answer as a fraction. So okay, so we're doing 2 take away 1, that's the whole part's done, and then we're doing 4/5 take away 3/4. Well, again, when we're doing takeaways, need a common denominator, so 20ths. Times that by 4, so times that by 4, times that by 5, so times that by 5. And 16/20, take away here 15/20 is 1/20. So we combine to get our final answer, which is 1 and 1/20. Okay, Sundas says that 4 1/3 is equal to 4.3. Sundas is wrong, explain why. Well, this is about remembering that 1/3 is not just 0.3, it's a recurring decimal. It goes on and on and on and on and on. So basically the explanation is that 1/3 is a recurring decimal, 0.33, not 0.3. So 1/3 equals that, not 0.3. This one says work out 2 2/3 times 3.5. Well, like when we're multiplying fractions, we are best just to have 2 fractions, not mixed numbers. So how many thirds are in 2 and 2/3? Well, 3 times 2 is 6, plus the 2 is 8, so that's 8/3. 2 times 3 is 6, plus the 1 is 7, so that's 7/2. And we're multiplying, so straight across the top, straight across the bottom. 8 times 7 is 56, 3 times 2 is 6. So we're saying 56/6, but it says it wants it in its simplest form, so that means we must remember to put back into a mixed number. So we go through our 6 times table. 6 9s are 54, so we're going to have 6 whole ones, and we've used 54 of those 56 sixths to do that. That leaves us with 2 6ths, but then we must remember that 2 6 cancels down, so it'll be 6 and 1/3. So again, when you're multiplying anything, if fractions involved or mixed numbers involved, then turn them into 2 fractions, becomes straightforward then, multiply the numerators, multiply the denominators. Okay, so this question says convert the recurring decimal 0.29, so remember that means it's going 29, 29, 29 and so on, and we're going to turn it into a fraction. So there's a little technique that we do. We let the recurring bit be x, and then we can create other equations. So 10x means we've moved this to be 2.929. So in other words, the two nines are just moved up. And so the recurring bit is now here, going 29, 29, 29, 29, 29. And 100x will make this 29.29 recurring. And this technique, remember, is all about getting point and then something, 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 where the recurring bits is next to the point. So we need the recurring bits next to the decimal point in two equations, and then that allows us to do some simple subtractions to get the fraction part. So we can see here that in the original fraction, in the original letting x equal this, the recurring part was next to the decimal point, so it's to the right of the decimal point, so next to it. This one, the recurring part carried on here, which is not next to the decimal point, it's the 9, not the 2. But this one, the 2, has come back next to the decimal point, so the recurring part is now there. So literally what we're going to do is we're going to do 100x's take away x, because that allows us then to have our recurring part next to the decimal point, and in this x it was the same. So in essence what we're doing is we're doing 29.292929 going on forever, take away 0.292929 going on forever, and what we can see, it doesn't matter how long this is, recurring obviously means it's going on forever, but it doesn't matter how long it is, every 9 will take away 9, every 2 will take away 2, and so on. So literally with this we're left with 29 here, and 100x's take away that is 99x's. So now we know that 99 times the x is going to be 29, so we want x, so we divide by 99, 29 over 99. 29 is a prime number, so this won't cancel down unless this was in the 29 times table. 99 isn't, so that is the answer, 29 99ths. So this technique is about getting the recurring parts next to the decimal points, so that when you subtract, all the recurring numbers just disappear, and whatever's left on the left hand side becomes part of the word to get the fraction. Change 3/11ths to a decimal, so 11 into 3. So we're going to say 11's into 3 doesn't work, so that's 0 points. Carry the 3 over, all remains get pushed over to the next one. 11's into 30, I'll go through our 11 times table, so it's 22. So 2 11's are 22, that leaves us with 8. Then it's 7, 7 11's are 77, take that away from there, we're left with 3. 11's into 30 is 2, remainder 8, and 7. So we can see very quickly that this is just going to keep going. 2 7, 2 7, 2 7, 2 7, and so forth. So 3/11ths is 0.27 recurring. This one is saying prove that the recurring decimal 0.39 is 13 over 33. So again, this is the idea of getting the 0.39 recurring bit next to the decimal point in two equations. So the proof bit is about giving some argument. So we're going to say let x, and we're hoping that x will become 13 over 33, because we're going to let x equal the recurring decimal, and then somewhere down here we'll have x as a fraction. We compare those two, and then it should be the same as what we got here. So we're going to say let x equal the recurring part. Then we go through the process of timesing that by 10 to create another equation, and so the 9 and 3 move up one place, so that means that will carry on doing that. And then we do 100x's, and then we end up with 39.39 recurring. So we've now got the situation where the 3 has gone next to the decimal point in two equations, the original one and the 100x one. So we can do the subtraction of 100x's take away x is going to be equal to 39.39 recurring take away 0.39 recurring. So again, we made sure that the 3 was next to the decimal point in two equations. It was 9 here, so no good to us. So we had to do 100x's, do the subtraction. 99x's is going to be worth 39, because those have cancelled each other out. And so x is going to be 39 over 99. Divide by 99 to get x on its own. We recognise both of these are in the 3 times table, so we divide 3 by 3. So 39 divided by 3 is 13. 99 divided by 3, 33. So what we've done, is we've shown that by letting x equal the recurring part, we've shown that x is this fraction. So we finish off by saying, so 0.39 is equal to 13/33. That's the way the proof works. This question says convert the recurring decimal 0.36 to a fraction. So again, it's this idea of saying let x equal the recurring that we've been given, and then go through the process of 10x's, 100x's, and sometimes you've got to go to 1000x's. It really depends on the numbers you've been given. But you just keep multiplying up by 10 to create two equations with the 3, 6 following the decimal point next to it. 10x is 3.636 and 100x is 36.36 recurring. So again, here's where our recurring parts, 3 is next to the decimal point with the x and 100x. So we end up doing 100x's take away x, and that's equal to 36.36 recurring take away 0.36 recurring. And again, the idea is that these will cancel each other out. Every 3 cancels a 3, every 6 cancels a 6, so you're left with the 36. And we've got 99x's. So x is equal to 36 over 99, but like all fractions, we must cancel down. Both of these divide by 3, so that's going to be 12/33. And then we'll recognise that this cancels as well, because both of these cancel by 3. So that's going to be 4/11. So 0.36 recurring is the same as 4/11. This one says convert 2.136 recurring to a mixed number. Well, let x equal 2.136 recurring. So 10x is going to be 21.36 recurring. Well, we've got the recurring bit now next to the decimal point here by doing 10x's. 100x's, so times this by 100 times this by 100. So that's going to be 213, 6, and then 3, 6. That's not good to us. So 1000x's is going to make it 2136.36. So now we've got two. Yeah, we've got one there, and we've got one there. So we've got these two where the recurring bit has gone next to the decimal point. So with this one, we're doing 1000x's take away 10x's, and that gives us 2136.36 with the recurring bit, and the 10x's was 21.36 recurring bit. So we do the subtraction, those cancel each other out. So we've got 2136 take away 21, so that's going to be 2115. So, and that's going to be 990 x 1000 take away 10, 990. So we're saying that x is going to equal, because we divide by 990, so that's 2115 divided by 990. So we've got a top every fraction here, and improper fraction. So we're going to have to turn that into a mixed number. Well, the original thing said 2 point something, so it's logical that it's got to be 2. 2 times 990 is 1800, 1980. Just check that. 1800 plus another 180 is 1980. Yeah. So if we do 2115 take away 1980, we'll take that up to 2000 is 20. So that's going to be 135. So it's going to be 2 and 135 over 990. But again, we should ask ourselves, does this cancel down? Because they're both in the 5 times table. So 5 into 135 is 27. And 5 into 990 is going to be, well, 5 in 1000 is 200. So we've got 10 short, that's 2 of them, so that's going to be 198. And then we ask ourselves, does this cancel down? And it looks like they both divide by 3. So we're going to end up with 2 and 9 and 3's into here is going to be 66. And then we notice that both of these divide by 3. So we end up with a final answer of 2 and 3/20 seconds. 2 and 3/20 seconds. Okay, so that was a run through of fractions and recurrent decimals, so from C grade up to A grade. Learn them well, guys. Common questions.